So we know how to take derivative of product of two functions. We know how to take derivative of sum or difference. We know how to take a derivative of quotient of two functions. So today we want to take this to discuss the case when we want to take derivative of composition of two functions. So the situation is the following. So we have composition of two functions, and we want to take the derivative. So if we want to take derivative of composition of the function, we'll need to use so-called the chain rule. So the chain rule. So if we want to take derivative of composition of the functions, f of u of x. So what we do is we take derivative of outside function with respect to inside, and we take derivative inside with respect to outside. That's a chain rule. And I'm going to show you a couple of examples on how to use the chain rule to take derivative of composition of the functions. So I'll start with a simple example where we have, say, function 2x plus 1 raised to the 10th power, and we want to take its derivative. So if you look at this function, we have inside part of it, inside, u equals 2x plus 1, and outside, u to the 10. So what the chain rule says, it says take derivative inside, so take derivative inside, it's going to be 2. It says take derivative outside with respect to inside, so derivative this one, so you get 10 u to the 9. And what the chain rule says now, take these two guys and multiply them. Take these two guys and multiply them. So we're going to get 2 times 10, and instead of u, because our original function in terms of x, we have to write down what u stands for, and u stands for 2x. Now we finish it by multiplying 2 and 10, of course, and final answer is going to be 20 times 2x plus 1 to 9. So let me run 2 more examples on how to do the chain rule. So basically our steps going to be, we need to figure out what is inside function, what is outside, take derivative of inside, take derivative of outside, take their product, and when we will be writing the final answer, make sure that instead of your inside function, you will write down the expression for it. So let's do a couple more examples. Derivative of square root of x squared minus x. So we need to figure out what is inside function, and we need to figure out what is outside function. Inside function is expression under square root, x squared minus x. Outside function will be square root of u. Now we're going to apply the chain rule. Chain rule says take derivative inside, 2x minus 1. Take derivative outside, square root of u. 1 over 2 square root of u. And now we're going to multiply these two guys. So final answer is going to be 2x minus 1 times, don't forget to plug in what u stands for. U stands for x squared minus 1. And we have our answer. Maybe the only thing is I'll do is combine that into one bigger fraction, but that's about it. So let me run maybe just one more. Divided by 7x plus 2 to the 5th, and we want to take the derivative of that. We want to do chain rule, and usually whatever expression in parentheses is a good candidate for our inside function. So in here we have 7x plus 2 in parentheses, so that is a good candidate for inside, and outside is going to be 3 over u to 5. Derivative inside is easy, derivative 7x plus 2 is 7. Here outside, it will not be difficult, we switch to negative exponents, 3u to a negative 5. So negative 15 u to the negative 6, so negative 15 u to the 6. And at the end, we multiply these together. 7 times 15 is 105. Minus. Don't forget to plug in what you stand for. And we have final answer. Negative 105, 7x plus 2 plus 6. That is application of chain rule. At times it is getting more complicated when we're taking derivatives. The complications arise when we have to do not just one rule product or quotient, or when we have to do a combination of those rules. For example, quotient followed by chain, or chain followed by quotient, or product with chain inside, or chain inside of chain, stuff like this. So let me try to do maybe one or two examples on that stuff. So for example, we have 2x plus 1 divided by x squared plus x to the fifth. And we want to take derivatives. So we see a fraction. So if we see fraction, we have to do the quotient rule to take the derivative of fraction. So I'm writing down the scheme for quotient rule. Okay, so now I'm going to plug it in. X squared plus x to the fifth, x squared plus x to the fifth, x squared plus x to the fifth. Okay. So I'm plugging in my denominator, now numerator, 2x plus 1, 2x plus 1. Now we'll have to take derivatives according to what my quotient rule says. Derivative 2x plus 1 is not difficult. Derivative x squared plus x to the fifth is a bit more complicated. I'll try to do it on the side. After a while, you will be able to do it without any troubles, just mentally. But for now, just a few times, let's do it and write everything down. So inside, x squared plus x, outside, u to the 5, derivative inside, 2x plus 1, derivative outside, 5u to 4. So multiplying these together, we have 2x plus 1, 5, and raised to the fourth, u, and u is x squared plus x. So I'm going to take this, and we'll plug in instead of this guy, which goes here. So 2x plus 1, 5, x squared plus x to the fifth, x squared plus x. We have x squared plus x raised to 5, and then raised to the second power, so we have 5 and 2, and 5 times 2 is 3. Okay. Now what is left is to simplify that expression, and the way we're going to simplify it is, so I keep the denominator as it is. On the top, I have x squared plus x to the fifth and x squared plus x to the fourth, so I can take x squared plus x to the fourth out. And what I left will be, out of first one, 2, x squared plus x to the first power minus 2x plus 1, and 2x plus 1 is 2x plus 1 squared, and 5 left. Okay, so that's the expression which is left. Now I can do a little bit of simplification here, because I have 10th power, x squared plus x, and I have x squared plus x to the 4th power, so I can reduce that into x squared plus x to the 6 on the bottom. And then, of course, here I'm going to multiply 2 out, square that expression, so I'm going to get 2x squared plus x minus 2x plus 1 squared. FOIL will do your favorite way of squaring the sum, so we should get 4x squared plus 4x plus 1. Distribute minus, distribute 5, distribute minus. So we have 2x squared plus x minus 20x squared minus 20x minus 5 over x squared plus x to the 6. So finally, after combining like terms, we should get our answer, which is x squared plus x raised to the 6th power. 2x squared minus 20x squared minus 18x squared, x and minus 20x minus 19x, and minus 5. So that is going to be our final answer for this problem. So you see what is complicated about this problem was that we have to do chain quotient rule. Inside of quotient rule, to take derivative of this guy, we had to do a chain rule. And after that, on top of that, we have to do simplifications. Okay, so that's example where we had quotient rule followed by chain rule. So let me try to do another example when we have to do maybe double chain rule. X squared plus square root of 2x plus 1 and raised to the 5th power, and we want to take derivative of expression. So let's do chain rule. So let's be inside. U to be usually a good candidate expression in parentheses. Outside u to the 5th. Derivative of outside, not a big deal. 5u to the 4th. Derivative inside, 2x plus, and we stuck a little bit on derivative of 2x plus 1. Okay, so I will do derivative of 2x plus 1, so on the side. Another chain rule. Inside 2x plus 1, outside square root of u, derivative inside is 2, derivative of root is 1 over 2 square root, and u stands for 2x plus 1, so we have 2 over 2 square root of 2x plus 1, do a little bit of reduction, and that goes into here. So that expression is 2x plus this guy, 1 over 2x plus 1 under square root. Don't forget to multiply these two guys together, and don't forget for this guy, inside function is that one. So we get our final answer to be 5 to 4th power this guy times derivative inside, which is going to be that expression. And that is going to be our derivative of this function. So it was 2 derivatives, 2 chain rules, one inside of another. One chain rule followed by another chain rule. So after a while it should not be that difficult for you to take derivatives, but you have to practice, practice, and practice.